Hello and welcome to another video. In this one, we're going to be talking about annotated tags in Git, and I have actually already made a video that covers this topic before, so check out this one. But it's kind of old, and I wanted to specifically focus on annotated tags. Weirdly, they've come up like 4 times in the last week for me, so I figured I'd throw something into a video. Also, I think I can explain them a little bit better than I did last time. Partially just because I have some more specific knowledge in some places, but also I think we'll be able to do a better job of showing that. We'll do a little paint drawing later. All right, so we are going to start with a Git repo. I guess I should say, like, what is a tag? A tag is meant to represent a fixed point in Git history. Usually it's used for releases to tag to mark the version that's been released. So like version 1.0 or 1.0.1, etc., etc. You'll make a Git tag that references that. Tags are very similar to branches in Git in that they reference a Git object. Usually that Git object is a commit, but we'll show with annotated tags that that is not necessarily the case. Also, I don't know why my camera is weirdly color balanced, but my hair is not actually red right now, so we're just gonna roll with it. What could go wrong? Okay, so I've made a Git repo here. We're gonna make some commits here. I don't know, just a couple of commits to have something in our Git log so we can look at it. And let's just do one line and we'll use decorate even though we haven't really decorated anything yet. Okay, so we have some commits here. The first thing that I want to show off is a lightweight tag, and this is the type of tag that I tend to use for the most part. And if we take our same history here, I guess we don't even have to represent it like that. Let's just, we'll open up Paint here. Yeah, sure, why not? And we'll have our, Git history over here. We'll represent it as a line, and we'll say that a particular commit on that Git history is a box. I don't know. So say this is like AB, whatever. This is our commit. This is a commit here. A lightweight tag, or the reference for a lightweight tag, lives in the refs/tags namespace. All tags actually sort of live in this refs/tags namespace. And if we make a tag, so git tag, let me remember the order of it. Is it tag name and then commit? Yes, otherwise you do it the other way around. Let's say that we're tagging 1.0.0 as this C2 commit here. If we look at git log one line decorate again, you can see now that we have added a tag to this repo here, and it is a lightweight tag. That is, it does not have other stuff. We'll talk about that other stuff in a second, but the nice thing about this lightweight tag, so say light here, v1.0.0, is this is just a pointer to a particular commit in the history. So you can see, I want curvy lines because curvy lines are cool. Yeah, look at that curve there. Nice. No reason for that. Anyway, so this is a lightweight tag. It is basically just a pointer into the history, and if we query the Git system for what its revision is, so if we do rev parse 1.0.0, this is going to match exactly the commit that it's pointing to, because it is just a reference. There's no other metadata attached to it. There's no message. There's no author. It is a lightweight tag. It is just a reference. In the same way that like a branch just references a commit here. So if I said git rev parse main, main, you're going to get exactly the commit here. Obviously, this is the short SHA, this is the long SHA, and this is a branch, and this is a tag. And if we look at git, is it git refs? Yeah. So git refs heads and git refs tags. You'll see that we have the branch, which is in refs heads, and we have the tag, which is in ref tags. If we actually cat those, this is sort of a little bit of internal Git mumbo jumbo. You can see this is how Git represents the branches on disk in the same way as how it represents the tags on disk. In this case, they are just pointers to those commit objects. Okay, lightweight tags, very similar to branches, just pointers to history. Now we get to the interesting part, which is annotated tags. With an annotated tag, there are several ways to make them. They have a message, and they have an author. They can have a signature. They sort of act like another separate commit, and they actually create a separate blob in the Git database. So let's make a new tag. Let's get that history again. I'm going to tag this commit as version 2.0.0. git tag v2.0 this, and I'm actually going to sign this tag, which I think is with little s. It's probably just dash dash sign, right? Dash dash sign. Okay, we're gonna actually sign this commit. Actually, no, I'm not gonna sign this commit because I don't want to type my GPG password into this. So let's actually just use a message instead. We do that with dash m, or with some option that opens up the editor. But we'll just do release v2.0.0. So we have a message here, we have the tag we're going to create, and the revision that we're going to attach it to. This actually creates not a lightweight tag, but an annotated tag. And so if we look at our history, it still sort of looks the same from this view, but what we've actually done here is made a heavy tag, or an annotated tag. And in this case, let's actually add another box here. This history is going the opposite direction, just because normally I like to draw the history as coming from the bottom up, but we're doing it from top down in this case. So we'll pretend like this is commit 2. Yes, the hashes don't match, but it is what it is. And we're gonna make an annotated tag here. So annotated v2.2.0. Now this is not just a reference to a position in the history, but this is actually a reference to a different blob. And this blob itself contains a reference to this in here, but this also has that message that we had. So like release, etc. It has an author. So like it knows that this is me, etc., etc. But this annotated tag is now a pointer to, oh, that squiggly line didn't turn out. Come on, squiggly line, whatever, it's close enough. We'll call it good enough. This annotated tag points at this blob, and then this blob itself points at the actual commit here. And we can visualize that in a second by using get cat file, but I just wanted to draw this out. So our annotated tag isn't just a pointer, it's a pointer to a pointer, or a pointer to a blob that points to this blob. And if we do get cat file, what is the option to make it pretty printed? Dash P, yeah, get cat file dash P. Well, actually, first we'll get rev parse 2.2.0. You'll see here that this B0, B5 doesn't match the commit that we're pointing to at all. This is actually that separate intermediate object that we have here. So if we do get cat file dash P this, you'll see that this object looks very similar to the commit object itself. So if we get cat file this is what, cat file dash P this is what the commit object itself looks like. It points at a tree, it has a parent, it has an author, it has a committer, and then it has a commit message. And it can also have a signature and the other stuff here. But mostly this is the data you'll see in a commit. And if we look at the one for the tag, we'll see that we have something a little bit differently. I'm not sure what this refers to. Oh, this is the commit that it points to, right? Yeah, FA0. So this is the pointer part of this annotated tag. It's pointing at a commit. It has this tag name. It has an author and a tag date time and a message. And sometimes you can have a signature here as well. So this is like a completely separate object from the commit itself. And so you can see kind of have this hop here. Okay, so why does this matter? And why has this come up so many times in the last couple of days for me? So the first part of this, or the first problem of this is, sorry, is this annotation object is actually sort of not really a commit and not really easily representable in the Git database. So for instance, if I do what? If I git checkout this object, it will work. If we check out the annotated tag object here, it will actually check out this tag object. But now that we've checked it out, you'll see that we're actually not at that tag object. Git has sort of implicitly taken this and found the commit that it refers to, and shown you that. Of course, you know, as we saw before with git rev parse, we're not actually getting that commit object back, so that part's a little bit annoying as well. So you can see here we're still seeing this object, but we really want to see the actual commit object here. And you can get back to the commit object by doing a thing that's called peeling, and I believe it is ~0. ~0? Yeah, okay, so this peels the tag. You can actually do this, I think, as many times as you want, because you can peel a peeled tag. And not that it means anything, but it's an idempotent operation. Also, you can peel a non-annotated tag if you wanted to as well. And obviously in the normal lightweight tag, it's just going to do the same thing. But this tilde0 operation allows you to get back to the original revision here. Now, another reason that this matters, and I actually have to find, one sec. I have to find a particular GitHub issue so I can show you an example of this being weird, which is this repo. Yeah. Okay. So if we clone this repo, GitHub hookin MD format, which I think redirects to a different repo, but it's fine. And we look at git rev parse 1.0.0 and the peeled version of this tag. You can see that this is an annotated tag, git cat file, git, we're gonna look at that actual tag, parse 1.0.0. And so you can see here, this is the message of that tag, and the author, and etc. But it is an annotated tag. Now, interestingly, if we go to GitHub here, where is my window here? hookin/md format /commit/this. So if we look at this actual commit object here on GitHub, it should render nicely. So like if we link to the actual commit, GitHub will show you a nice thing. Annoyingly, if we link to the tag object, this here, GitHub's not going to show anything. Oh, I clicked in the wrong spot. GitHub's going to be like, what are you doing? 404. That doesn't exist. Honestly, I think GitHub could improve a little bit here and just show the commit or like redirect the commit, but it doesn't. And maybe that's intentional, maybe it's not. But it's a little bit annoying. And so this is one of the like tiny differences that I've found between these two. Also, various systems will choose either of these revisions based on, I don't know why they picked one or the other. For instance, pre-commit, the tool that I wrote, uses this one because I mean it's the obvious result from git rev parse. But I think what is it called? Dependabot uses this other one. GitHub's UI uses the other one. I don't know. It's kind of arbitrary. But anyway, that's annotated tags. They're a little bit different than lightweight tags. Hopefully this makes a little bit more sense than the last time I explained it. Although I probably should have rewatched that video to see exactly what I did there. Oh my goodness. Now my alarm's going off. Can't have nice things today. Anyway, I hope you found this interesting. If there are additional things you'd like me to explain, leave a comment below or reach out to me on the various platforms. But thank you all for watching, and I will see you in the next one.